Hello, this is TLV with another episode of 100,000 Diamonds Plus. And I hope you're ready for the coding part. Today it's balls deep, seriously. Alright, my quarry has stocked up on some items. I'm running the other Frame Quarry at the moment and it's ravaging the landscape. I hope you're ready here. Today we're gonna start coding and I hope you follow me. I'm gonna explain what I do. In my very quick basic tutorial I just got you kind of to understand what kind of operating system this is. I didn't explain a lot of commands. And we'll do it meanwhile we do this program, so you can... It will be like a tutorial as well, I think. Because you can see and understand what I do. And you will understand. So for example, let's get our operating system and a blank floppy here. I had it before, but cheat them in again. They're so cheap to make anyway. Let's put in the operating system, restart the computer, and we're on it. We got 8,792 bytes of data. All my other words are gone. It starts with words, cold load here. So everything is gone, fucking hell. So we can see that it works. Let's see. At the left side of the screen you can see that it works now. 1 IOX. Doot, doot, doot. You can see it, I guess. 0 IOX. Doot. Turns it off. Now we're gonna make some programs instantly. We're gonna make some words for the most simple stuff that we want our Frame Quarry to make. We want to make a program called dig. And now we could turn the IOX, for example, IOX, 1 IOX, we'll then wait, and 0 IOX. But I'm gonna make a cool system here. I'm gonna start this with a do loop here. For example, 10, 0, do. It's a for loop that will run 10 times. It starts on 0 and we'll run it 10 times. Starts on 0. And this is the operation, do. But I'm gonna leave out the 10. I'm gonna start it with 0. So the user have to define the 10 before starting the program. Has to put a number on the stack. First in, first out, as you remember. Do. Now we wanna wait. This is the wait command in fourth. 20 ticks is 1 second, so this is 1/4 of a second. Then we activate our IOX, number 1, this should be the dig. Then I want to wait maybe 15 ticks, so in total 1 second. Then I want to turn off the IOX. And then this is the finished program, the finished loop. And end the program. What this has done is, let's see, let's run 2 dig. So this number 2 here will actually go inside before this 0 in the do loop. Alright, so it will run this loop only twice. Actually, 1, 2. Okay, actually I'm gonna forget this. I'm gonna delete this program. Can easily, we haven't written any code yet, so we can just restart the computer to make sure we have all the memory available to us. I'm gonna make if in fourth, if you do a do loop 0 0, it will be an infinite loop, and we don't want that shit. That piece of shit. So we're gonna do a special do command here. Dig 0 question mark fucking question shit piece. There. I have a weird keyboard setup because I have added several languages to my computer. Do. Is the question mark in front? I think it is. This do loop here is the same, but it checks. So it checks for infinite loops and it won't execute them. 5 ticks again. Let's write it the same. IOX1. 15 ticks wait. Turn off the IOX. Loop the program. Finish the program. Let's see. 3 dig. 1, 2, 3. Good. This should be our go left, go right in the quarry. So let's see here. Dig L. I'm gonna make this slightly different. 0. Do. Let's see what we want. Before it starts, 5 ticks is good. 5 ticks, yeah, so it doesn't start immediately. Just for safety measures here. So you don't want the stuff to overlap each other. Just give it some waiting time for the computer to realize what the fuck it's doing. I want the 2 IOX. And now I think we want to wait 50 ticks. Because it has to move 2 frame motors. And I think 1, no, maybe 1.5 seconds. 50 ticks. That's 1.25 seconds per motor. 2.5 seconds in total. Is that enough? I really hope it is. But the good thing about this is, if it's not enough later, we can just redo this small little dig L program here. So it's not a big disaster if it doesn't work. 50 ticks should be fine. Yes, hopefully. I really hope so. It's gonna be tight. Maybe I have to do 60 ticks just to be sure. What should I do? What should I do? No, that looks bad. 60 ticks, 3 seconds, 1.5 each. Let's go with 50 ticks. Fuck it. Fucking hell. Don't be such a pussy about it. Turn it off. Loop the shit. Bam, bam. Done. We're good there. We're not gonna do all of them right now. We're gonna do a bunch. Dig right. 0. Do. 5 ticks. 4 IOX. It's all binary. 50 ticks. Turn the shit off. Loop the bastard. Boom. And now we're gonna use tell the frame arm to do what to do. Let's call it frame arm down fat. I wish it was fag, but okay. Frame arm down. Fad. Yeah, fad. I think this one also needs do. Or maybe not. Yeah, it's gonna be fine. Maybe I did this way of doing it. Maybe it's gonna be more complicated for me to code later. That just hit me. Why can't I add a fucking question mark? Fad, okay. 5 ticks again. It's 2 motors, right? No, it's 1 motor. Plus adding. This can be slightly faster, I think. 8 IOX. Let's do 40 ticks. Should be okay. 0 IOX. Loop. Good. Frame arm up. Bow. We want to do the same here. Do 5 ticks, 16 IOX, 40 ticks, 0 IOX, loop. Gonna do left from on the quarry. I think I'm gonna do the same here actually for all of them. So I'm gonna 5 ticks, 32 IOX, 50 ticks, 0 IOX. This is just the beginning of all the fucking code later. Holy fuck. Right. Oh, annoying. This is annoying. 5 ticks. 64. You see the bits. We're running out. It's gonna be fine, I think. 50 ticks. IOX. I hope I really didn't do any typo. Forward. Come on. Shit. Do 5 ticks. And it's also case sensitive as well. IOX. 50 ticks. 0 IOX. Loop. No. Case sensitive, like I just said. Fucking hell. Last one. And we're done. Do. Ooh, maybe go enter the program first. 0. 2. 5 ticks. 256. Oh wait. 50 ticks. 0 shit. Loop the bastard. Loop de la loop. Good. And if you leave the computer, it's still on. So now we want to take out this floppy here, the boot operating system, because we just booted from it. Put in a blank floppy. Put the operating system in here. We want to save this shit. Save. FK Frame Quarry 2. So now we don't have to redo this. Good, I got these programs done. Now let's add some other important programs here. We're gonna start with an alias. Variable is the command to make a variable, but it's pretty long. So I'm gonna make an alias for this. Var, call it var. And semicolon. It's gonna do the same thing as variable. Good. Complete. And now we're gonna make a string. How to make strings. We have to make that ourselves, how to make strings. It's not defined in the program. And I think I want 32-bit strings here because I don't know what we run into later. 32-bit string. A lot reserves a special memory of 32 bits in the memory somewhere. I don't know where, but that's what it do. Then we want to swap. It swaps the latest 2 in the queue, latest 2 value with each other, and like a 1 2 swap will be to 1. So you get, it's an easy command. So we're gonna swap the address and the value here from what we get later when we read. Swap, and then write it back into the memory. And turn off the program. So this program will be linked with our read program, how to read variables. Let's call it read. So this will this will take stuff from the memory here. So this at sign here will basically, we will have said variable ASDF. We make a variable as, and that we'll just do this, take out the inside of it, and since it's a string up here, it's gonna swap it later, and we're gonna accept something from the console writing. So that's what we will do. At 32 bits, let's make something to write. Tung 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 colon. Space, yeah, space. I want space. One more space. And I want accept. Now we can read from the console our variables, because we want to define them ourselves, don't we? How big the quarry is going to be, etc, etc. So we will call upon this program here. So we have to make all the programs in the operating system ourselves. It's pretty fucking annoying. That's read for you. Now I want to use the dollar sign here for my variables. I'm gonna have an x value. In the direction it's gonna move in the x value. We're gonna make a variable called x value, and a variable called y value, in which direction to move in y, and I'm gonna make a variable to play around with, when to compare and to count, and just something to back these guys up. So let's call that temp, and let's make all these guys as strings, so we can actually extract what's inside these memories. String. We're just calling up on the other program here. String here. So we allocate memory. So by calling this variable a string, what we basically do is we allocate 32 bits of memory, and we swap it and write it back into this guy here. This is very comfortable using smaller programs in bigger programs, right? String. My value string. Temp string. Whoo! Let's save again. I don't want to redo shit, so save. Oh, it's loading. Now I think I'm gonna make this cooler. I'm gonna even make more variables here for forward. Instead of using numbers, which is easier, I'm gonna use variables, because it's cooler. Yeah, it's not that difficult. Okay, see you next episode, where we continue this fourth tutorial, making machine / whatever shit piece of crap. Oh, see you next time.